This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seberg. Hello, Robert. Hello, dear listener. Nice to have you with us.
And Peter, welcome to the podcast. Let's start with the news part. I will start because my first news is not really an AI news.
Oh.
But I have to pay my respect at this point because Philipp Paschen, the CDO of SIEMENS, is a friend of our format and is building a new factory in Germany. The company invests over 40 million euros, over 700 new machines. It is to be a smart factory, Philipp told me. And AI will also certainly play a role, and it's great. I think that's such a mid-sized company. You know, SIEMENS is investing so much money in Germany and in technology. Congratulations, Philipp. It is always a pleasure to see how you handle your digital strategy. It's great. Congrats.
We visited Philipp and his team at their original site, I believe. Is that right?
Exactly. At the original site, and they will move out of the city and build a complete new smart factory outside. Yeah.
Yeah, that's what you typically see or hear. You know, companies making room free in the city and go outside. Yeah, that's amazing. I think I read some. I don't recall in detail. There's specific technology that they are moving out or are going to continue to work on, and as I believe you said, maybe with even deeper automation integration.
Exactly. More deeper automation integration. They designed the shop floor totally new, and I'm pretty sure that machine learning and AI will, as I said, certainly play a big role in this new factory.
Maybe he can share. Maybe he can tell us about it sometime. Yeah, it's great to hear. I mean, it has been for the last couple of years really that automation, and specifically then also, of course, artificial intelligence has become like an opportunity rather than a threat. Now, still, now and then there is a listener, you yourself, other people who are maybe a little bit afraid, scared of what is coming. But as long as you prepare yourself, and that's what you're doing, you're listening to our podcast, and that's very good. No, but it's really true. And make sure you're gonna be able to understand what the technology can do. And Philipp, as a CEO, has understood it, and he sees the opportunity to.
I think he's the CDO, Chief Digital Officer.
Oh, he is a CTO, right?
I think his father is the CEO. I'm not sure, but he's not the CEO.
Oh, right. Okay. Yeah. But in the management team has understood that, they can, with help of technology, they can move further. And then always the problem is we don't find people anymore. So, and the people that he has, he's going to continue with. And you and I were there to tell everybody about artificial intelligence.
AI in the canteen. Yeah.
A wonderful combination. Yeah.
Yeah. And my second news piece, I will go on, and then it's your part, because there's a connection. Because I spoke to Jan Kautnik. You know Jan, I think, 5 years ago, Hannover Messe.
Exactly.
Formerly nascent and now with his own company. And he told me, yes, GenAI is pretty well and good results, but we also need more. And then this quote, I think it's very interesting, more blue collar AI. I think that's a nice quote, blue collar AI.
You have to explain it maybe.
From his point of view is AI applications for the people on the shop floor that really solve problems on the shop floor, really problems, and not knowledge management topics at the machine. So the really shit things on the shop floor to be solved, the heavy things, the complicated things. And that's very interesting because everybody's focused on Gen AI. It's fine, it's good, it's well, but we need also to focus once again blue collar AI.
That was confirmed by a study. I forgot. Maybe you saw it as well.
It was Google, right?
It was. At least they paid. They paid for the study, and it said that making exactly that differentiation between the white collar workers in the offices, with the white collars. That's where the bigger share of Gen AI today was happening more than in, for example, in industrial environment, the shop floor. And that's exactly what Jan is saying. Yeah, Jan, who 5 years ago with Festo at Hannover Messe was, right?
Yeah, absolutely.
Was saying that soon reinforcement learning, I think that specifically was what we were talking about, was going to design the new shop floor, so to say, so the new production lines. And I'm very much looking forward to, at some point in time, I think he's going to join us as well.
Yep.
In October, so to talk to him.
In October at our event, yeah. But it's funny because today we have once again a Gen AI episode in the main part where an AI explains source code. That's very interesting. It's a opposite way not to write code, to explain code. Very interesting. What's your news?
Yeah, I was going to talk about, I saw that, everybody doing new chips, NVIDIA, ARM, and I was going to talk about those. But then I thought, let's talk a little bit of a different story. I may have mentioned a piece or two of this. Just remind me if it gets too boring. But I'm going to start off with a story which was happening in Japan, and that's when is that? As you said a couple of days ago, everybody else around me is younger than I am. So it must have been the 1980s. So Seiko Instruments, sister company from the watch company, Seiko Epson printers, etc. And I visited a couple of times a year. And at that time, I was there together with Nigel from Ambitron, I think. And we were there to learn about the GR4400. And that was a graphics machine. I actually did find this time a piece of information from Computer World, 1987 it was. It was introduced by actually Seiko from the United States. Now, long story short.
Yes, short please, Peter.
Yeah, we were there Monday morning at 9 o'clock, and we had already received our 400-page manual. And now certain listeners will get a feeling for where I will get to. And then the Japanese colleague was in front of us, we were two, and he started reading sentence by sentence the manual. That was very interesting. And I think Nigel and I looked at each other and thought, what is this? Are we going to sit here the complete week and he's going to read the manual? So we changed that and we were going to do exercises. Now, what this manual is let's say what today is a library. A library, that was the library of commands, how to develop applications for this huge piece of equipment. It was so impressive. It says here 400,000 vectors per second, wire transformation. That was 1987. Very, very important. So if you wanted to produce a circle on the screen, you had a command circ 100, 150, whatever. And then, then the machine, which was a code interpreter, would produce a circle on the screen. That's not different from what today is the big reason NVIDIA is the number one graphics AI chip company in the world, is because of their software. It's because of CUDA.
CUDA. Yeah, CUDA.
CUDA, right? CUDAs. So, and that's really what I wanted to say. So, and I just looked at it for a quick moment here. So the same way that you did at that time, make a function call, circle, whatever today. And I read here CUDA is about 400 libraries. They have, microservices libraries too. So it's a complete environment, mask libraries, parallel algorithm. And I never went into the details of this one. So if I make the link between my circ call of the GR4400 and CUDA, that's completely my assumption that is correct. If it's not, I'm happy to listen to any comments from you, dear listener. So, but basically, so if now, and they say they have 4 million developers who have written code, so there must be like billions of code. Very interesting than the topic of today. I haven't heard it yet, that you now have AI looking exactly into the code and interpreting what the code is. So this company, or what is it then? The coalition of tech companies, and that's including Qualcomm, Google, Intel, a couple of others. So they want to break the NVIDIA grip on the market.
The UXL Foundation.
Exactly. So they may then be very interested in the topic that you just mentioned that we're going to be listening to later on, by AI then being able to interpret existing billions of lines of code. Because the only way to break, that's what I'm completely convinced of course, on one hand, there's always the hardware. And there have been many, many, many more companies in the last 10 years to design chips, not to produce chips. There's only 3 companies in the world who can really do that at that level. And there's even a smaller number of companies who can produce the equipment to produce. And we talk to those companies as well. So that's really the point, again, I wanted to make. And I don't know exactly how they're going to do it. You mentioned it, UXL Foundation, right? There's a piece of technology developed by Intel. It's called One API. In the end, it's not really different from the 90s. That was Intel. I think at least there was like an IP with AMD. So, of course, I did see that NVIDIA does have maybe it's only a small part of the CUDA is open source. I didn't see it with the other pieces. So potentially they could say, okay, here's our libraries. If you pay us money, you can use it. I'm not sure that that's what they do. If one of you, dear listeners, know, I'm interested in learning more about that. And the other way is to just kind of reverse engineer. So if you're going to have developers develop, let's say, GenAI applications, and you're going to make a function call to whatever kind of, let's say, machine learning algorithm, you want to make sure that behind the processor receiving the command can understand what it means. So if your processor talks CUDA, and then maybe we get into a legal thing here as well. Is that allowed? Is it not allowed? I'm not sure how they're going to do it, but I'm just want to share that, the core way of what NVIDIA did. Now, they say that in 1999, they invented the GPU. That's what I do not understand, because what I just talked about was 1987. 10 years earlier, there was this machine that was full of graphics processing units. Maybe they weren't called like that, but doesn't matter. And CUDA is from 2006.
I know that CUDA was a huge topic at ZEP's LSTM, ex-LSTM, because you need to hire engineers who can do that at the end. And these engineers are rare, and they are expensive, and they need money to hire these engineers to solve the CUDA stuff.
So now we're full circle. Those are engineers that maybe were not sent to Japan, but wherever. No, but it's exactly the same.
Yeah.
So they know they can, those software programmers, engineers, of course, they know CUDA by heart. They know if it says 400 libraries, they probably don't need to know all 400 of them. But it's really about the same thing. Knowing, when I want to make a function call to a very specific whatever mass library, I know exactly how to do that, basically, right? And that's what they will have been trained on, and that's what those engineers, those of you listeners, have been coding for many years, and you know exactly what I'm talking about, and that's why you are worth what it is that you're worth.
Exactly. So I wrote to the UXL Foundation an email.
All right.
To invite them in our podcast. To tell us a little bit more about their approach. And I recorded an episode with HPI, and we also discussed a bit about the UXL Foundation. But I'm pretty sure they will come to the podcast and tell us a little bit more what is their plan to do.
Now, in the end, what is the value of all of this for you, listener, depending on who you are? If you're a developer of systems, then today you have very limited potential of buying graphics GPUs. You're almost limited to whatever they are called, but in the end, it normally says NVIDIA typically. So if you're a developer, that is very important. If you're not, if you're a user, then in the end, do you care? Well, as far as all of us care is that, and actually also the organizations like FTC, they care if there's only one. We at Intel at that time, we had legal training, and it was very clear that as far as Intel was concerned, they were at that time, and I'm not making legal statements here, I want to be careful, but they were at that time very big in the microprocessor market. So they were not like, owning the total market. So if you split up the market segment, then that's easier. Now, for all of us, it's important if there's not just one, but 2 or 3 or 4 companies. It's very typical that when there's competition, we get a better performance per price, lower price, better performance. So in the end, if there's other companies being capable of, taking share of that market, in the end, that should be good for all of us.
Do you have still one more news?
No, that was it for today.
I have my last news because I did a recording with ZETI. They published a report, State of AI Talent. And I can tell you this much. Siemens Healthineers, Bosch, Bayer, and BMW are leaders in Germany when it comes to attracting AI researchers and AI talents. And I will put the link to the report into the show notes. Attention. It costs money, so stay tuned for the May episode because there we recorded the whole episode. And yeah, it's a very interesting report on the state of AI talents. If you want to buy it or wait until May when we have our episode.
All right. Yeah, I looked at the headlines. Yeah, I was rather impressed. Almost like it was not that negative about, all the talent is only in the United States, only in California. That was not at all. It was almost like the other way around.
He said Germany performs very, very well. Germany, the Netherlands, and the Scandinavian countries performing very well. UK also. Italy, Spain, France have little problems, but it's not like this.
Very good.
It's a very interesting report. Yeah. Perfect, Peter. Let's switch to the main part and talk about GenAI and how GenAI explains PLC source code.
Very much looking forward to, as we just said.
Thank you very much. It was a pleasure. Bye-bye.
Thanks, Robert. Bye-bye.
My guest today is Josef Waltl. He's the founder and CEO of Software-Defined Automation. And we met a few weeks ago in Berlin and had a little chat. And now we are recording an episode. Welcome, Josef.
Thank you. Welcome. And thank you for having me.
Yes. Before we start, Josef, please introduce yourself briefly and what does your company Software-Defined Automation does?
So I'm Josef. I'm the CEO and co-founder of Software-Defined Automation. We are an industrial automation company. And what we do is very simple. We do basically what the cloud companies like AWS did for the computers in the data center in the early 2000s, where they moved from having people to go into the data center, update applications manually, to having everything in a simple software console. And we do this for the compute instances called robot controllers or programmable logic controllers in the shop floor.
But today we don't want to talk about this specific use case. We want to talk a little bit about your GenAI approach, right?
Yes, this is what comes once we've done job zero, how we call what I just explained.
Yeah. What is it and how does it fit in your overall approach?
First of all, really listening to our customers, as any company does. And
that's a good decision, I think, yeah.
What our customers and our users are the automation engineers. And if you then go into the day of an automation engineer in former times had a laptop with different types of industrial automation engineering applications on, from Siemens and Rockwell and Bosch Rexroth and so on. And the control files on different controllers that control conveyor belts, all types of machines and robots are not only adapted by one person, but by several persons. And they sometimes come from the machine builder, and then the staff maintenance automation engineer needs to look at it. And here is a very concrete problem is that, first of all, this software is not very well documented very often. The second thing is people do not know what's the latest version. They don't know what the changes are. And these things really matter. What do I mean with that?
Why? Explain us in 2 sentences.
First of all, if something breaks, very often it breaks for software because there is a parameter, a control loop that is not kind of working anymore with the changed hardware. Yeah? And the other thing is, if something breaks and it is because a change that has been made by someone before you, you want to undo it. But if you don't know where it is and what it really intended, you cannot undo it. And this leads to, I would say, very bad things up to machine and production downtime. So a favorite quote of a lot of our customers is, if we have an outage, it's not because of bearings wearing out. It's not because of the hardware. It's almost always because of the software. So we don't have that transparency. And then we have a source code quality that's not exactly on a level that is optimal, to say it the least. So a fact is that a lot of automation engineers spend a lot of their time in looking at code and trying to make sense of it. It's called reverse engineering. And this holds them back from thinking of, how can I also automate this additional process? We don't have enough people to produce all the goods we need in our societies. So we need to automate more. Automation engineers are highly trained individuals. It's at least as complicated as being a general IT software developer, and you have all those hardware and electrical components in addition. But if those people spend a couple of hours per day on trying to make sense of what's really going on, that's like waste. And what we did is we, first of all, with our platform, bring the latest version to their disposal or to their understanding, because we have a Git-like repository. Those versions are very often binary, so we unpack them so we can read the real source code. Source code can be textual, like structured text. It can also be graphical, like function block or ladder logic. And what we've then done is we applied AI, specifically large language models, to explain source code in real language.
Stop, one question. So it's a kind of translator? Because when we talk about with LLMs in engineering, it's always to say, okay, we will write code with LLMs, or we will add code, and we will add code to our PLC programming. So it's the opposite to translate code, right?
We would say explain code.
Explain, okay.
So we come back from what's the problem of the people in a night shift. And it is understand the existing code. And then technically it turns out that it's like an order of magnitude simpler to generate perfect new code than to explain bad code from 20 years ago. That is maybe documented in a language that you don't know. We have a customer that has machines that are documented in Italian, and the customer is in Germany, or not documented at all. So we solve a very pragmatic problem, like get people up to speed. And I think this is what customers of our company like, because we really kind of build from ground up. What's your pressing problem? We build a solution. Of course, we will translate or evolve into code generation, but we want to do that on a base of really understanding what's going on in the current machines.
So how does it work in practice now? We are in the night shift. What has the employee to do?
So first of all, he does a backup, presses the button. A couple of minutes later, the latest version is in our cloud console. That is still, in the case of Siemens, binary file, SEP 17, SEP 18, or whatever. We then invoke an application or an action that's called decomposition. With that decomposition, we can show every function block, every hardware configuration in the file in the browser natively. So no IDE that is vendor specific required, no license for that IDE required. And then you just click on a function block and say, okay, browse through. I do understand it. I do not understand it. And if it's something where you say, okay, this will take me maybe 2-3 hours to understand it, you can click the button and say, explain it to me. And then it takes around 50 seconds, depending on the length. And then you get a 6 to 10 sentence summary out of it, and you get a summary of the I/O tables called, like the input-output tables.
How accurate is that?
That's a very good question, and I can tell you how we approach that. So a explanation of an industrial control code needs to be accurate, meaning it is right, and need to be complete. And we test that in a panel of automation engineers, where every automation engineer has more than 10 years of experience. Domain knowledge, and it needs to be even specific. It needs to be, if we do it for Rockwell, it needs to be Rockwell domain knowledge for Siemens. So, and what we then do is we give them a task, give them a program. We have some test programs that have like non-speaking variable names, no documentation. Yeah. And say, okay, look at a program and write a 6 to 10 sentence summary. We measure the time and we have certain metrics on how accurate it is. And then we compared it with what the 6 to 10 sentences our model generated. And if you then go around accuracy and completeness on a scale of 1 to 10, it needs to be and. Yeah. So it can be 100% accurate, but not complete. Means this is a function block. 100% accurate, 0% complete. We started with just putting it into ChatGPT, and this was a 2 to 3 based on the judgment of our panel. And now we are an 8 to 9. That means 10-year experienced automation engineers need 3 to 4 hours to come up with an equal description. And that's like 50 seconds. And we cannot reveal pricing now. We will do by Hannover Messe at a very affordable price or 3 to 4 hours. That's the real impact of what we do.
And how do you solve that? Or how do you achieve that? What is the magic, Josef?
There is, of course, some kind of simple sauce, but in that sauce is a lot of blood, sweat, and tears. A lot of trial and error, a lot of domain knowledge. So we have basically a team that does nothing around since years of just optimizing that simple domain-specific applications. And it is a lot of prompt engineering, it's a lot of optimization, and it's some pretty advanced models how several LLMs interact with each other. And I hope you understand that that's how far I can go so far. It's not space magic. We just build a very specific application for industrial automation.
You mentioned more than one LLM is part of this solution, right?
Yes.
So you're working with different providers of LLMs.
That's also correct.
So can you name, do you work with Mistral or is it a Llama or is it a OpenAI approach?
So we started out with OpenAI, and then our rest of our application is on AWS, and we are now seeing best results with AWS Bedrock and various models that are available from AWS Bedrock. We can be more specific in a couple of weeks where we are at Hannover Messe, but what we can clearly see is that the AWS approach of giving you an easy access to all types of models that constantly evolve is very attractive for a software company like ours because it gives us maximum freedom.
Can you share a little bit, once again, how do you train these models? And do they evaluate the translation or the explanation, your domain guys? And how do you do that practically? So you give them code and they should write it down, or how does it work?
So let's start with the last one. So first of all, how do we test? We have a PLC program. That PLC program is simple or complicated. We have 3 different levels. And the simple level is like short and well documented. And the worst, more complicated, is like sometimes several files. Like if you, for example, have a Ethernet protocol that you implement. You have logic for the stack, you have a packager, you have data blocks and so on. So it does not even need to be one file. This can be interrelated. And we also have files that have like obscured variable names. Like you can have a variable that is called timer, or you can have XY77. And then it's not speaking, it's complicated for human and following also for LLM to understand. So we do have those sample programs, and we come up with new ones all the time. We then take those and give it to our panel and say, okay, look at that program. How long will this take you? Sometimes we also let them write up a comparison, like, please explain that to me. And then we let our LLL run. And then we have that text with the original and the text and compare it. And then we have the same panel, but we mix around and say, okay, please judge which of the comparisons is better. And therefore, we kind of get to a higher win rate of our model being better than the explanation of the humans. Is it perfect? No. Is it applicable for a shop floor? We believe absolutely yes, because that's kind of the comparison you have. It's the comparison to your existing staff engineers, and you want such a model or such an application to be comparable with or better than your staff engineers as a fraction of time and at a fraction of cost, which we achieve. I also want to kind of specifically go into the cost level, because it's not all about the functionality. A lot of the engineering we do is to make it accessible. So I give an example. If I have a machine and the machine costs like $1 million and I have lost all control code And we have customers that have that.
Really?
Yes, we have customers that say, this is a machine that runs for 10 years. No one touches it because we don't know what happened. Like sometimes machine builders go out of business or something like that.
Yeah, sure.
Or you are a Rockwell customer and that is in Siemens or in Beckhoff or whatever. These things happen. Like I learned a lot in the time since founding SDA, what's really happening on the shop floor. Some parts of it is really frightening. With no critics to the people, it's just the state we are. And if the explanation of the code will cost you 800,000, it's not going to happen. Yeah? So we really need to bring it down so that it is approachable by the individual engineer. And that's something that our company is really focused on. Because only an accessible application is also software that ultimately, or application that generates value.
Yes, I have one more technical question. Maybe you can answer it. What role does retrieval augmented generation plays in here? Or is it not a RAG approach you are using there?
No, currently we don't do that. So in a future state, we will be much more customer specific. And then we can use all types of individual training applications. But there, a couple of things need to happen. And I give you an example. There has been this case where Samsung engineers put in questions on code generation into ChatGPT. And now if you ask the right question, you can get code examples of Samsung chips. That's not what you want if you are, for example, a producer of ball bearings and all your IP over the last years is in the control code of the grinding machines. Or if you are a German car maker and you're so proud that your sheet metal aligns perfectly, your core IP, if quality is your core of your brand, is sheet metal presses and body and white shop, control code and optimization over decades. And you don't want this in a public model. And therefore you need to generate a highly secure, that I would say, repository where you first of all can have your code. This is what SDA is. So there is work to be done to make that trading possible. And this is the groundwork that we do. But then once you have your own model, and this is something that we will come to at some point in time, that we allow that for our customers, that you have customer-specific models that are highly secure, that are trained. And then you can say, you know what, I have this car and I have a couple of brands and it's basically the same car. And I have this car body moved around with a KUKA robot in factory A, and in the same in another factory, I have more or less the same car body, but it's an ABB robot. Make me an ABB program that does exactly the same. That's the power that's going to happen. We are not there yet because we are focusing on public models, to be clear, but we have the base platform to make it secure and do that in the future. And especially as you asked me about specific models, the AWS approach is very software developer friendly for us because it allows all that. So you can have your own model in SageMaker. That's one of the AI support tools from AWS. And that can reside in your platform, and we can kind of isolate it for specific customers. Because as I said, the implicit core knowledge of manufacturers is very often in the robot and control code.
Now I'm a machine builder and I'm listening to this episode and I ask myself, how do I integrate now your approach into my shop floor? What do I need to solve before?
First of all, the base code needs to be in our application.
So I need to buy the whole stuff from your company?
Not necessarily. So first of all, there is no buying of stuff. We are a service company and we only charge for actual usage.
Okay, perfect.
So for a machine builder, this could be very cost effective, to be very clear. We don't believe in a couple of things. We don't believe in a world where someone charges you up front, where it's not clear if you are using it. The second thing is we don't believe in software that is closed and doesn't have an API for everything. Because in the future, innovation will manifold, and there is not such a world where you can guarantee that one vendor will provide you everything, and whenever you need a feature, you need to beg there. And we believe everyone should build on top of our software whatever they could do. So to go back, to be able to get access to the source code of binary files, you need to have the binary files decomposed into readable files. That happens in our platform because it's one of the services. And the second service is then to explain it, or what we did not touch upon right now is we can also explain differences. So for a machine builder, for example, you have core engineering, and that kind of, if you build bottling machines, for example, then you have core engineering, and those guys kind of make better programs for PLCs to put a bottle cap on a bottle all the time. And then there is a specific machine that goes to, let's say, India. And on that road, there is the own integration unit there. And then there is maybe the customer or system integrator and so on. So these PLC programs will have a lot of alteration until the bottling machine has its application in a certain factory in India. And we can because we can do automated backups, we can bring that back into the repository as a new version. We can decompose, and we can also compare. We can compare and say, okay, this is the difference between these two ladder logics. You can look at it, but we can also explain the difference in clear language. And
you can also suggest improvements?
We've not implemented yet, because we are, first of all, focusing, as I said, on bringing this explanation.
But this is an idea?
Absolutely. There is this, I have an Amazon background. I don't want to hide it. And there's this saying it's always day one. So for SDA, in terms of our capabilities, we are, of course, in day one, but we not even reach breakfast in terms of capabilities that we can build on top of it. The hard thing is really kind of make a Siemens and a Rockwell and a Beckhoff PLC behave exactly the same for the user. What we now do is like really kind of double down on productivity features. And technically we can, of course, like most models can generate code. So we can go from code to explanation. We can go from prompt to code. So at some point in time, there might be even a world where it can go from one code to another code in a certain stack. We don't want to make promises, but technology is definitely there, and I can see actually LLMs evolving quicker than we expected. Just look at Claude 3, yeah? Like the benchmarks, yeah?
Share a time horizon for us to code.
So let me put it this way. I think it will be much quicker than we all expect.
So at Hannover Messe?
At Hannover Messe, we will have our code explanation service, which we called Factory Agent, for explanation of source code in clear language and explanation of differences in source code in clear language in production at a very affordable price, so that people on the shop floor in the night shift with a tight budget in automation engineering can use it. That's the most important thing.
Share the price with us, Josef.
That will be by Hannover Messe, but I understand. I appreciate that you ask. You do a good job here.
Hannover Messe is the partner of this podcast, so please, you can share it. That's no problem for that.
That's no problem, because that's really good, because we will be in Hall 9. It's basically exactly between Beckhoff and Siemens. You find software-defined automation, and I will be able to, at Hannover Messe, who is the partner of this podcast, inform our customers about the price. What I can say is that we work very hard in achieving a very affordable price. What I just wanted to say on the time horizon, I believe it will be quicker than we all expect. I also believe that it will start with a developer-guided approach. What do I mean by that? I think we will be quicker as we expect at a stage where we can say, you know what, this is a Siemens program and I want to move it to Beckhoff or whatever, the other way around. And here's an 80% version, but here's the things where you should look at and double click and confirm. And that confirmation will go down over time, but to have it perfect, I don't know if we ever reach that. But I think that's not the point. The point is that you massively reduce the effort. So we have a customer that we frequently talk to. They are in the energy business. They have two separate teams, one in the US, one in Europe, building exactly the same control software for an energy component, one on Siemens, one on Rockwell. And I think even if we get to 80%, like it reduces most of the problem of those people, because you can use those engineers to build a better core application, and the rest is just bringing it to one platform or the other.
Josef, what are your tasks in the coming months? Please share with us. What are your plans to do?
First of all, we have customers really rolling out.
Which branches do you focus, or do you have a focus on branches?
We don't have a strict focus on branches, but we see certain patterns in different branches. I can walk you through. So one of our customers is Henkel, that's public. And what we see in consumer packaged goods, they have a lot of factories, and all of these factories are super huge. Some of these factories have a variety of different controllers. And it's like really getting control, having the backups, and having one system to really support the automation engineers on the ground and really getting efficiency. In addition, we see interest from also the security in this vertical, because you now get a different level of security exposure, and I can tap into that a bit. What we see from automotive, they are more standardized. So they're our platform. It's the same technology, but helps to kind of bring more standardization in. And I give you an example. You could also ask the LLM, give me an example. All of these automotives have standards for controller programs. Not every supplier adheres 100% to the standards. You could go in, make a backup and say, okay, give me an analysis of per function block, how much that function block, which is an element of an industrial controller program, adheres to a certain standard. And that gives you a different level of control. And you can go back and say, hey, by the way, you delivered that machine a couple of years ago. We just did a check and we found out that there might be something you want to look again at. But then we have companies in logistics and packaging where we have just massive growth. It's like the question is, if you need to build a fulfillment center every 6 months, then you might not want to have like the same 3 months for software commissioning for every center if it's essentially the same center. Like what you can do with our base platform is you can control copy, control paste for the automation stack in a fulfillment center. And what we then see in oil and gas and more process industries, it's really security. It's like this mean time to recover. It's like if we maximize it in our platform, it's a couple of minutes for hundreds of PLCs. That might take a bit longer, but currently that there has been this incident with the Colonial Pipeline in the US. This was like 3 months, and we can massively reduce that. So it's interesting because we see the same technology, but the focus per vertical is a bit different depending on their challenges.
At the end, I have one more question. Why can only you do that? What is your specific domain knowledge that you are capable to do that?
Again, I think there is no secret sauce other than a lot of blood, sweat, and tears. What we have been able to collect a set of people, which I'm very proud of, especially our engineering department, that has deep understanding of industrial automation, of the challenges and of the technologies, has at the same time understanding on what is the best state. Like what we really do a lot of is first principles thinking. Like say, okay, why does it have to be a Windows application to program a robot or a PC? Oh, that's not a physical rule. Like how would it be done? And then we figure out, we start small and then we expand together with our customers. So what we do is a lot of hard engineering. The base premise of our software company is very obvious. It's not genius, it's very obvious. It's just very hard to do. And we are willing to put in all the hours and all the effort to make the life of our customers easier. And that's it. There's no secret thing.
So, Josef, we are looking forward to see you at the Hannover Messe. We are looking forward to hear the price at the Hannover Messe. And I think it's a very interesting approach, very smart approach, and it will help the industrial sector a lot. All the best for you and your great team and your company, and best wishes to Munich. Thank you very much.
Thank you very much.